Students, look at this root map question where we are going to start with C6H10O. It is going to react with methyl magnesium bromide followed by hydrolysis. I know that normally this Grignard reagent reacts with carbonyl compound, so I'm going to start with the carbonyl compound that looks like this, C6, right? Let us show C6, then double bond O. Let me check. 2H, 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 total 2, 4, 6, 8, 10, 10H. 6 carbon are there, 1 O is there, everything perfectly matching. So I have a clear idea that Grignard reagent normally react with carbonyl compound. On that basis, I wrote what is C6H10O is. Now I know whenever carbonyl compound reacts with Grignard reagent followed by hydrolysis, the shortcut I know, the only change I am doing is O into OH. Am I right? Now look at carbon valency, 3 satisfied, one more is H2. That one more will be satisfied by R of the Grignard reagent. What is R? Methyl here. So this is nothing but Q, okay? This is Q. This is Q. So anywhere they are mentioning about Q? No, they have not mentioned. Now let's go straight. Q is reacting with a concentrated HCl. I'll just write here the Q. I'm writing CH3OH. It is going to react with a concentrated HCl. I know that this is H plus. This is OH minus, go out as water. Because minus went out, there is a formation of plus. I can see over here the carbocation. Look at the nature of carbocation, 1, 2, 3. It's already tertiary carbocation. Whether we want any kind of rearrangement, no. It's already tertiary carbocation. What we are expecting we have here. Now the plus will be attracted by the minus Cl. Done. So this is what I will get as S. Now let me check S given same can be S anywhere else. What is option C? So option C, that is S, right? This is S. But here this is wrong. S given here once again wrong. So option C, option D we can rule out. We are only left with option A and option B. Okay, let's go ahead. I have a Q. You come down. Phosphoric acid at 360 Kelvin. I know it is dehydration reaction. Dehydration reaction. Alcohol, acid, dehydrating agent. Now I'm going to talk about dehydration. This is beta elimination, right? Beta elimination. I know this is alpha. I know this is beta. I know this is beta. I know this is beta. So you know that OH will go from alpha. Beta should lose H. Dehydration reaction. Now, which beta carbon you will choose to remove hydrogen from it? You know, whenever you have this kind of ambiguity, which rule we are following? We are following Sedzeff rule. We are going to follow now a Sedzeff rule. According to Sedzeff rule, we should remove hydrogen from that beta which has least number of hydrogen in it. It has a 3 hydrogen, 2 hydrogen, 2 hydrogen. These two are identical. Okay, I am removing hydrogen either from here or here. It's one and the same. It will not make any difference. So I am removing H from here. I am removing OH from here. So between this alpha and beta, single become double. So this is nothing but R. Is there anywhere R is under scrutiny? No. So nowhere there is talking about R. So let's go ahead. Which side we want to move? Let's see. We have a product R. I'm writing it. Looks like this. Yeah, let's go this side. Yeah, fine. HBr, benzoyl peroxide, alkene. You know, addition of HBr to alkene in the presence of peroxide, it follows what rule? Anti-Markovnikov rule. I should know that the moment I will see HBr peroxide, it is anti-Markovnikov addition. anti-Markovnikov addition. According to Markovnikov, rich become richer, the poor become poorer. Anti-Markovnikov, rich become poor, poor become rich. See this. This is rich, right? It has one hydrogen, it has no hydrogen. So rich become richer, rich become poor, taking up the negative part. And poor become rich, taking up the positive part. So H will be added up here. And this is what U. This is what U. U is given exactly same, no. So this is the right answer. Whether given U here, yes, it is given. Okay, still we are in a doubt now because U is given in both the ways same. Correct? Yeah. Let's go in a other way. We are moving in this manner now. So what is R? Let me bring it back to R. So here, hydrogenation in the presence of nickel catalyst. I know addition of 1H here, 1H here, so double becomes single, no issues. Now we are doing bromination in the presence of sunlight. You clearly know that whenever we talk about sunlight or peroxide, we are talking about which rule? Free radical mechanism. I hope everyone got it clear. Sunlight, free radical mechanism. Where free radical is most stable? Tertiary free radical is most stable. If you remove H dot from here, I know that it's a free radical mechanism where a bromine undergo homolysis. So you get bromine free radicals here. If you remove H dot from here, what free radical you get? Primary free radical you get. If you remove H from here, you will get tertiary free radical. See exactly, there is H here, right? So you show H dot is going with a Br dot to produce HBr. Now, because you removed dot, another dot remain, right? What is the nature of this free radical? 1, 2, 3. Tertiary free radical, most stable free radical. Am I right? Now, what is left out? Br dot. That Br dot will attach to this dot. Together it will produce us a stable molecule. Now this is nothing but T. Now tell me whether it is given as T. Though this is already right, I told it. T, you look at this. Whether they are same? No. Means here T given wrong. So option B cannot be the answer. So option A we have to tick it as right answer.